Hello there, and welcome to our lesson video about multiplying radical expressions. That is exactly what our learning target is, multiplying expressions that contain radicals. So a few things to keep in mind if you've never really thought about multiplying radicals before. Here's the rules. First of all, two numbers that are outside of a radical, so clearly 2 and a 5. You know, they're not inside a radical house, they're just two numbers hanging out. When you multiply them, since neither of them are under a house, you can multiply them like normal and get 10. If they both were under, let's say, a square root house, it could have been a cube root, it could have been a fourth root, I just picked a square root house, okay? If they are both under, I am allowed to multiply them and write them together under one square root house to get square root of 10. Now we dealt with this when we talked about rationalizing radicals a few days ago. Okay, now some things to keep in mind. If, let's say, the 2 is outside and the 5 is under, I don't know, I'll say a cube root house, it doesn't matter. If the 5 is under any sort of root house, a radical, I cannot multiply and get 10. Okay, I would simply just keep them where they're at, the 2 outside and the 5 inside. Okay, now finally the last thing I want to mention, what if I've got this, the square root of 2 times the cube root of 5. They're both under a house, however, do you think I can multiply them and get some root house with a 10 under it? I actually cannot, since they're different roots. This is understood, remember, to be a 2. So this is a square root house and a cube root house. I cannot multiply them and get a 10 in any way because we're talking about two different things, two different root houses, so it's not going to happen. So you would just rewrite it. You would have the square root of 2 times the cube root of 5. Okay, there's no way to combine those. So these are some things that you've got to keep in mind as we look at these expressions. As far as multiplying, though, we kind of do the normal thing. You know, we're going to distribute here on this one. I'm going to distribute in the radical 2, but just remember, if you can or cannot multiply the numbers. Goodness, if I could talk, that would help. Okay, so square root of 2 inside, the 2's inside, times a 4 that's outside of a house. Can I multiply and get 8? No, I can't. I would keep the 4 outside, the 2 inside of the root house. Okay, minus square root of 2 times square root of 8. Since they're both the square root house, I may multiply them and get 16. However, you must always give your answers with radicals in most simplified form. So this 16, you should factor tree, and I can hear the moans and groans already. Okay, the root house, I'm looking for pairs, so I have a pair of 2's and another pair of 2's. So for each set, one of those 2's comes out. So since I have 2 sets, 2 2's would come out, and I'd multiply them to get a grand finale of 4 radical 2 minus 2 times a 2 would be a 4. Okay, and that would be an acceptable answer to multiply. All right, rock on. Let's look at another one. Again, I'm going to distribute in the square root of 5 times a 3. Can I multiply and get 15? 5 is inside, 3 is out, so that's how I've got to keep it. 3 square root of 5. Oh, this should be fun. We've got square root of 5 times 2 times square root of 15. Can I multiply the 5 times the 2 and get a 10? No! One's out, one's in, so 2's staying out. However, can I multiply square root of 5 times square root of 15? I actually can. All right, and that would give me what? 15 times 5, square root of 75. But like I just talked about on that last one, you're not done. You got to factor tree this bad boy. So 3 and 25, and then 5 and 5. Oh, I'm looking for pairs, because you know there's a little 2 on that root house. Bada boom, bada bing, I got a pair of 5's. So here's what's going to happen. From this set a 5 is going to come out. But there's already a 2 out there. So do I add them and get 7, or do I multiply them and get 10? Ooh, hopefully you're yelling out at me, 10, 10. Yes, multiply them. And then whatever was left, that 3, goes back under the house. So in case you're watching, here's just a quick recap. To get the 10, what we did is the 2 that was already there times the 5 that we had a pair of. Okay, so that's how I got that 10. So there in the green is what I would say my answer would be. Okay? Oops, that's the same one. Let's go to the next one. Oh, foiling. Awesome. Okay, now, I think just to help stay organized, maybe you might not have to do this, but I'm going to do this old school way of foiling just because with radicals, I think it helps keep everything organized. Maybe some of you have learned to foil using this grid thing, where you write the binomials off to the side. So like this first binomial, 2 square root of 7 would be this first row. And then because it's a -4, I'm going to put -4 in that second row. And then this second binomial, the first column would be square root of 7, and then a 1. Positive 1 because it was a plus, okay? And then in each corresponding grid, you know, you multiply the respective things together. So with radicals, this might help us. 2 cannot be multiplied by a 7, so we're going to have a 2 outside, times square root of 7 times square root of 7. I am allowed to do that and get 7 times 7, square root of 49. But square root of 49, you guys really should get to memorize some of these. If you did a factor tree, you'd have a pair of 7s, because clearly that's how we got 49 to begin with. So really we're doing 2 times 7, which is simply 14. So I've got a 14 in this first grid. Okay, I guess I could have made my grid a little bit bigger. Now, in this second, I'm just going to go across the row. 2 radical 7 times a 1. The 2 and the 1 can multiply together, but it just stays a 2, and we just keep the radical 7 attached. I'm going to move down to the second row. -4 times a 7, can I get 28 when I multiply? No, the 4 is out and the 7 is in, so keep them that way. -4, radical 7, okay? And then finally, -4 times a 1 is simply -4. So what the idea to this game is to combine like terms. So let me grab my highlighter. I've got 2 terms with radical 7s, so I can actually combine them. And then I have, let's see, what else do I have? I have a 14 and a -4 that I could eventually add together. So as a final answer, what we would say, if I add the -4 and the 2, I would have -2 radical 7. So I simply added the 2 things highlighted in yellow. And then when I add the 2 things highlighted in that turquoise blue, I would get 14 plus a -4 would be simply a +10. So I would write plus 10. Okay? Now, you could also maybe write it this way, 10 minus 2 radical 7. These 2 are interchangeable. It doesn't really matter the order, just as long as the signs are right. The 10's positive, the 2 is negative. Okay? Alright, so you don't have to do this grid, but if you like it, I think it's kind of helpful. Let's look at this next example. I'm going to make the grid again. Okay. I wonder if I can... Yeah, this is a little easier, putting in my own little graph here. Okay, so I'm going to translate this first binomial as 3 negative square root of x, because of that minus sign. I'm going to have 1, and then positive square root of x. And I'm just going to multiply like we did before. 3 times 1 would be 3. 3 times the radical x, obviously the 3 stays outside. Okay. Negative radical x times a 1, -1 square root of x. Okay, the house was negative, and that 1 has to go in front of the house, so it turns into a -1. Or else you could think of it this way, there being a -1 in front of him. -1 times 1 still is -1. Okay, negative radical x times radical x. Well, I could do this, make it -x squared, okay, because the x times the x. But then if you think about a factor tree, you break it up, x and an x, and that's a pair. So an x would come out. So really, I'm just looking at a -x, okay? And then I want to consider my like terms to be able to combine together. So I've got this radical x term and this radical x term that I'll add, okay? So we're going to have, I'm going to start with the yellow highlighted stuff first. -1 plus a 3 would be a 2 radical x. And then I got this loner constant 3 plus 3. And I've got this minus x. Now again, you can put this in any order. It's just the order I'm going with. Okay? Now, this guy, what if you've got something squared? Well, what does it mean to have something squared? Well, you know, 3 squared means 3 times 3, and you hopefully would tell me that that's 9. So to square something means to take it and multiply it by itself. So here's my suggestion. Forget the square. Multiply this guy by himself. That's what it means. Okay? So then it looks like those other problems, and I can just fill in my grid. Square root of 15, -3, square root of 15, -3. Okay? And multiply like things. So in this first grid, I'm going to have square root of 15 times square root of 15. Okay, you know what? 15 times 15, I don't have my calculator handy. Yeah, you could put this as equals the square root of whatever 15 times 15 is. But think about it. When you factor tree it, you're going to break it down to have a 15 and a 15, and there's your pair. Okay, so whenever you have a radical times itself, that cancels the radical, and it equals whatever the number was. Okay, or letter, like the last one was an x. And then let me just go through and fill in the rest of the table. -3 is out, square root of 15, 15's in. -3 is out, 15's in. -3 times a -3 is a positive 9. Add my like terms. So let me get my highlighter. The 15 and the 9, and then the radical 15, radical 15. Okay, so add my like terms together. Let's add the blue stuff first. So -3 and -3 would be -6 square root of 15. Ooh, that's a bad 5. Okay, so -3, -6, radical 15. Add the yellow stuff, 15 and 9, 24. So plus 24. Again, could be flip-flopped in order, but this would be it. All right, let's see. What do I have time for? I definitely want to do one of these, and this might be it. Okay, so kicking it up a notch. Let me fill in my grids. 8 cubed root of 2x minus 4. Notice my root house changed. That's important. No longer are we looking for pairs, but we're looking for triplets. Okay, whoops, that should have been a 1. Okay, so multiply like things. So now here, in this first grid, I've got 2 numbers that are outside that need multiplied, 8 and 5, to get 40. And then inside, the 2x and the 2x would give me a cube root of 4x squared. Now I'm stuck with that because I don't have any triplets inside of there. Remember, our root house changed. Now this 8 cube root of 2x times a 1, well, that's just going to stay itself. It's cube root of 2x. In this next row, 5 times -4, -20, cube root of 2x. Since the 5 and the 4 were both outside, I could multiply them together. And then simply -4 in this last one. So think about your like terms. What can I add together? And it'd be this guy with this guy. All right, so I think I'm going to start with this top corner box. 40 cube root of 4x squared. Add the yellow stuff together. So -20 plus an 8, since they're like radicals, would give me -12 cube root of 2x. And then just attach that -4 at the end. Okay? So that's going to be it as far as my examples for this video lesson. This one really is about as hard as they get. Here are your preview problems. Make sure you have these done for next class. I will be checking them as you walk in. So keep learning and have fun, guys.